Hi, welcome to Video Math Lessons. Tonight we're going to be doing pre-calculus. The topic will be functions. In particular, we'll be doing logistic functions. So before we start talking about logistic functions, what we need to review is exponential growth functions for a second. So exponential growth functions. So we have exponential growth. The thing about exponential growth, it is unrestricted. It is unrestricted. Well, what does that mean? Well, it just means it keeps going forever. It just keeps growing. So if I had an exponential growth, it just keeps going up forever. It doesn't stop. Well, when we talk about logistics, we're going to be talking about there's something up top that's blocking it from going any further. So what happens is if there's a limit. So if there's a limit upstairs, if there is a limit to the growth, it is bounded. And that's the case we're going to have tonight. It's called bounded. So that's what we're going to have tonight with the logistic functions. So let's take a look at an example. So they give us two formulas, two different versions of the formula. And you're going to need to memorize the formulas. You have to just know the formula. So it says f of x equals c over 1 plus a times b to the x, c over 1 plus a e to the negative kx. Well, what you need to know is that the a, b, c, and k, they're just constants. They're positive constants. All right, so those are all constants. But the c value upstairs is very special. The c value is actually called the growth limit, or limit to growth, however you want to phrase it. It's the limit to the growth. So what that's going to do is that number is going to determine what I can max out at. So let's just say the c value is up here. So that's that's where my max is. It's actually a horizontal asymptote at c. So this is going to be y equals c. That's the upper bound. But there's a lower bound down here at the bottom. And that's going to be y equals 0, the x-axis. So this is actually bounded. It's bounded below and above at y equals 0 and y equals c, whatever the c value is. And what's going to look like, it's a curve. It's kind of like a tilted letter S. So it's going to come like this, come across and switch. Oops, don't go below. So that's what it's going to do. It doesn't go below. That's our logistic curve, that tilted letter S shape. So let's look at an example of it. So now I added all this. So let's talk about this. You have to be really careful, and you're going to need parentheses around the bottom here. But then even in particular with this E thing here, you're going to need it around the variable, the exponent with the variable in it by itself. So I already punched mine in. So why don't you punch yours in, and this way we can take a look at it. So 100 over parenthesis 1 plus 20e, another set of parentheses, negative 0.7x. We're not using we're using t as our variable, so we just use x. Close, close. And I could hit graph right now, which some of you would be tempted. And that really doesn't look like my graph. Doesn't really look like my graph. So let's look at the questions, what they're asking us here. It says, first off, what is the growth limit? So the growth limit is the number up top. So the growth limit is 100. Now in the other drawing I showed you, 100 would be the top, the upper bound, the asymptote. Well, my graph is only going to 10, so you need to fix your windows. So I'm going to press window. I'll leave the x's for now, but I know the y value has to go to at least 100. Maybe I'll call it 120, just to get a little bit of headroom on there. Okay, so it looks something like that. And 100 would go right along the top here. So that looks pretty not horrible. That actually looks pretty good. So adjust your window to fit your screen. Well, we just did that. Sketch neatly and accurately. Okay. Well, let's see where it's going to cross the y-intercept. Now you could plug in 0 here to get the y-intercept, and it's going to be some decimal, right? Because it's going to be 20, and that's a 1, so it's 100 over 21. Well, it's around 100 over 20 would be 5, so it's close to 5. So it's like a 4-point change. So, it's way down here. So it's not going to be totally to scale. But we're just going to do our best. And you can see where it maxes out up here at 100. So I'm going to draw my horizontal asymptote at 100. And I have another horizontal at the bottom. So this has 2 horizontals, one above, one below. Sketch neatly. So, and with this the digitized pad, it's a little tricky. So I'm going to come up like this. And, some kind of S shape like this. Tilted S. This could be a little nicer, but that's all right. And I'm just going to call this F of T. Notice our variables match. There's a T in the problem. There's a T in my function. And I call this, technically it should be T and Y, but usually we just call it X and Y anyway. Where X is our T value, so I would call it T. Sketch neatly and accurately. Got that. What are the horizontal asymptotes? Well, we already mentioned it. So it was y equals 0, the x-axis, and y equals 100. Part E. Find the value of t, so what time, to the nearest hundredth, so 2 decimal places, that the function equals 75. So what I'm really doing is I'm setting this f of t to be a 75 over here. Well, you could do like cross multiply and a bunch of division, and then you'd have to do logarithms to get the t down on the ground. But I have this nice graph over here. Let's do something with the graph. So I go down to y2, and I'm going to type in 75 because that's what I'm looking for. And I hit graph. And I can see that it hits here nicely. And I can find this point. I'm going to use the calculator. We're going to press second calc intersect. So second calc intersect number 5. And down at the bottom saying, is this the first curve? You just say yes. And you can see the equation at the top changes. Y2 upstairs now, so just say yes. And I need to guess. You could even leave it there. They only cross at one spot, but you can move it closer if you wish. That's good enough. Hit enter. And that's the value. So we said find the value to the nearest hundredth, so 2 decimal places. So it's going to be 5.85. So that's logistics. You have to know the top number is going to be your maxed out number. You got a y equals 0 as your other number, your other horizontal. And either by using the calculator or logarithms, we can find the value of t at a particular number. So that's it. So thanks for watching, and hopefully it helps you. Have a good night.